Hello students, today we'll take topic virtual work. This chapter is there for only autonomous institution. It is not there for Mumbai University students. This virtual work method is alternate method to solve the problems of equilibrium. In the chapter Equilibrium of coplanar forces, we had solved the problems by using equilibrium conditions. In this method, we give displacement to the body, and then all forces acting on the body will do the work, and algebraic sum of the work done by all forces is equal to zero. That's what is the condition which is called as principle of virtual work is applied to solve the problems of equilibrium. All the problems of equilibrium of coplanar forces can be solved by principle of virtual work, but we will restrict to what is normally asked as per our examination. So let's start with in detail. Let's first start with definition of virtual work. You have a body which is under the action of certain forces and it is in equilibrium. Now, suppose the body is given some virtual imaginary virtual displacement, then each of the forces will do some work due to this displacement. Work done by the force due to small virtual displacement, the body is called as virtual work. Work done by the force due to small virtual displacement given to the body is called as virtual work. Now, what is principle of virtual work? You have a body under the action of certain forces and it is in equilibrium. Now the body is given some virtual displacement consistent with the geometrical conditional system. And so certain forces will do work, certain forces will not do work, but algebraic sum of the virtual work done by all forces acting on the body will be zero. So you can say that sum of the work done by all forces will be zero. That is like what we applied in equilibrium condition. Sigma fx is equal to zero, sigma fy is equal to zero, sigma m is equal to zero. Here sigma u is equal to zero. So algebraic sum of the work done by all forces acting on the body is zero. That is what is principle of virtual work. Now, here there is a in the definition we have used the word consistent with geometrical condition of the system. That is what is the meaning of the geometrical consistent. Suppose you have a straight bar. So you have to give the displacement to the bar in such a way its straight nature should not be disturbed. I mean, you should not bend the beam. You can rotate it, you can take it up, you can take it to the right, you can give the virtual displacement in any manner, but it should not be, its geometry should not be disturbed. Right? Suppose you have L-shaped piece. Two parts are welded together rigidly at 90 degrees. So you have to give the virtual displacement to the body in such a way that their geometry, that their two parts are meeting at 90 degrees should not be disturbed. Otherwise, principle of virtual work is not going to be. All right. Now there are certain note which you should remember. What is work done by a force? Work done by force is force into linear displacement. What is work done by movement? Work done by movement is movement into angular displacement. Virtual work done by inclined force is equal to the sum of the work done by its two components. Work done by force will be positive if point of application and the direct point of application moves in the direction of force. That means displacement and force are in same direction. Work done by force will be negative if one is in opposite direction. I mean, force is acting, suppose downward, displacement is upward, then work done will be. So these are some of the basic points related to the principle, related to the application of principle of virtual. Now we are ready to start with the problems of type 1, which I put it as problems based on regular sign convention. Regular sign convention means work done by force is positive if the force and displacement are in same direction. That is what is the meaning of regular sign convention. So first in this lecture, we'll cover the problems of beam reaction type. Now this is first problem we are taking. Find the support reactions for the beam shown in figure by virtual work method. Describe the beam reaction problems. We have done it in equilibrium chapter also under at the heading equilibrium of general force system. But the same problem, instead of solving by equilibrium condition, we will solve it by virtual work method. You will see that the difference between equilibrium conditions method and virtual work method. Now, we have drawn the free body diagram of the beam. What we have drawn in free body diagram beam, we have shown the reactions V and V. This load moment are shown as it is. This UDL is replaced by equivalent method. What is that? 4 into 4 is 16 kilonewton. Now, to find reaction V, this beam is straight beam. So straight nature should not be disturbed. So I'll rotate the beam A by small angle theta in anti-clockwise direction, as you can see there. this beam, straight beam A, is being rotated about A by small angle theta in anti-clockwise direction. So that anti-clockwise direction, so that you can see that if you are rotating about A, there is no displacement of point A. So all forces acting at A will not do work. Here, here certain assumptions are to be made in such a way. That is, first you have to assume that theta, the virtual displacement by which you have rotated, angular displacement to the beam, is very small. If it is very small, tan theta can be taken as theta. I have written it under the note. All right. When you are rotating it about A, VA will not do work. Now you can write the virtual displacement in the direction of various forces. See, if tan theta is theta, then virtual displacement in the direction of 8 kilonewton will be 2 theta. Here it will be 4 theta because it is at distance 4 meter. Here this is 6 theta. This is 8 theta at this point, and last is 10 theta since it is. So simply we multiply angle theta by the distance from the point about which it is rotated. This is a 2 meter, 2 theta. This is a 10 meter, 10 theta. This is a point is at 8 meter, 8 theta. Now we will apply principle of virtual work in the problem, right? Now can you see that? I'll write it as mechanism 1. Number 1 I have written, that means first part we are defining it mechanism. Mechanism means we have displaced the body. Displaced body is called as mechanism. Now you can see that VA will not do any work, right? We algebraic to find V, rotate the beam by small angle theta about A and apply principle of virtual work. How you write it mathematically? Principle of sigma U is equal to 0. That means algebraic sum of the work done by all forces equal to 0. Now let's start from here. See, 8 kilonewton is acting downward. The point of application is shifted upward. So work done is negative, minus 8 into 2 theta. Because this is similarly, after this we come to the 16 kilonewton. This 16 kilonewton is acting downward. This is the point of application which is shifted upward. So work done is negative, minus 16 into 8 theta. V is acting upward. Point of application E is also shifted upward. So work done is positive, V into 10 theta. All right. Then you have a movement also. This movement is acting on the beam anywhere will give same effect as in equilibrium conditions also. Movement is clockwise. You have rotated the beam about in anti-clockwise direction. So work done by movement will be negative. 20 into theta. Negative. Minus 20 into theta. Minus 8 into 2 theta. Minus 20 into theta. 20 into theta is work done by movement. Minus 16 into 8 theta. And plus here just there is a small correction, students. It's not equal to, it is plus sign has to be there, equal to 0, right? So one plus sign and equal to 0. So then minus 16, that theta will go off from all the terms. Theta will go from all the terms. Minus 16 minus 20 minus 128 is equal to 10V, right? Equal to further we simplified, use calculator, V comes out to be 16.4 kilo. So algebraic sum of the work done by all forces will be 0. Now we understand second part of the. Now to find VA, we will rotate the beam about E by small angle theta in clockwise direction in such a way that VE will not do work, VA will do positive work, 8 kilonewton will do negative work, 16 kilonewton will do negative work. As the beam is rotated about E by small angle theta at 2 meter away, virtual displacement of the this point where 16 kilonewton is acting is 2 theta. This is at 4 meter, 4 theta, 6 theta, 8 theta, 10 theta. It is like R theta. You can say that. So we are assuming theta is very small. So that means this and this are like the two radius. And this will be R theta. This is a 2 meter, 2 theta, 4 meter, 4 theta. At 6 meter, 6 theta, 8 theta, 10 theta. All right. Then we apply. This is mechanism 2. Now, algebraic sum of the work done by all forces is 0. VA will do positive work, VA into 10 theta, minus 8 into 8 theta. Since 8 is acting downward, displacement is upward. Work done by movement. Movement 20 is acting clockwise. This time beam is also has been rotated in clockwise direction by small angle theta. So plus 20 into theta, minus 16 into 2 theta equals 0. So here the expression has been written properly. And theta will go off from all the terms. And if you solve it, you get V as 7.6 kilonewton. Is that all clear to you? This way we get the reactions in a simply supported beam. Normally, for finding the reactions in simply supported beam, you can just rotate the beam. You can see that we have preserved the geometry. Beam A was straight. right? So we have kept it straight even when it be rotated it about A about theta or about E by theta. Okay. Now we take second problem of beam reaction. Beam is hinged at A and roller supported at B. First, we have to draw the free body diagram of the beam. Hinge will exert two reactions. Roller will exert one reaction. Roller is resting on a plane making 30 degrees with horizontal. Reaction normal to it will make 30 degrees with vertical. So RB is at 30 degrees vertical, RB cos 30 and RB sin 30. Then at A, there is a hinge, so two reactions, HA and B. 20 kilonewton is the load acting vertically downward. By mistake, it is a 10 kilonewton meter. It is not meter, kilonewton. I hope you understand. 20 kilonewton, this is 30 kilonewton. And this UDL is replaced by 5 into 5, that is 25 kilonewton. And this 15 kilonewton meter is external movement. Is that clear? Now, this is one means mechanism one. That is the first part. To find the RB, we rotate the beam by small angle theta about A, so that HAVA will not do work and only RB will do work. All right. Now, this point where 20 kilonewton is acting at 3 meters, so this displacement in the direction of 20 kilonewton is 3 theta. This is 5 meters, so 5 theta. This is at 7.5 meter from point of rotation A, 7.5 theta. This is at 10 meter. This is 10 theta, right? So we apply principle of virtual work. Now start from the left hand side. Minus 20 into 3 theta, minus 30 into 5 theta, minus 25 into 7.5 theta. All these forces are doing negative work. So those forces are acting downward. Point of application is shifted upward. RB cos 30 is upward into 10 theta. Will do positive work because force is upward and even point of application is shifted upward. RB sin 30 will not do any work since we assume that theta is very small. So point B and B dash are assumed on the same vertical line. Similarly, HAVA also will not do any work and be equated to 0. Then from the entire expression, theta will go off. Theta is the virtual displacement which gets cancelled from each term. Then RB is obtained as 44.17 kilonewton. All right. Then we come to second mechanism where we want to find VA. To find VA, as in the previous problem, rotate the beam by, about B by small angle theta in clockwise direction. So that virtual displacement of point A will be 10 theta. This point is 7 meter away from B, 7 theta. This is 5 meter. So this is 5 theta. This is 2.5 theta. Let's apply principle of virtual work. VA will do positive work. HA will not do. HA because there is no horizontal displacement of point of application. BA will do positive work because BA upward and point of application also is shifted upward. So VA into 10 theta positive. Minus 20 into 7 theta negative. Since work done by 20 kilonewton will be negative because force is downward, point of application is shifted upward. 30 is also negative, minus 30 into 5 theta. Minus 25 into 2.5 theta. Work done by movement will be this time negative. Why? Movement is anti-clockwise and you are rotating the beam clockwise. So work done by movement will be negative. That is what is 15 into theta. Whereas in the previous mechanism, the movement was anti-clockwise, rotation was anti-clockwise, so work done was positive. You can see that plus 15. So this way, if you solve it, theta gets cancelled from all terms, you get VA. Now you are left out with HA. To find HA normally in the beams problems, you simply shift the beam towards left or towards right by displacement, linear displacement delta. So we have shifted this to find HA, give the linear displacement delta to the beam towards right. So that A gets shifted to A dash, B is B dash. So this is delta delta. So work done. Only in this mechanism or this kind of the virtual displacement to the body, only horizontal forces will do the work. So HA will do positive work because HA is acting to the right and displacement is also HA into delta, positive work. RB sin 30 is to the left, but point of application is shifted to the right. So work done by RB sin 30 will be negative. So minus RB sin 30 into delta, right? So then delta delta gets cancelled. You get HA is equal to RB sin 30 is equal to 44.17 sin 30 is equal to 22.09 kilonewton. Now we come to the third problem. Lever mechanism shown in the figure is used to lift a weight of 1 kilonewton using principle of virtual work. Determine the value of P required to lift this weight. This time you have a beam which is bent at certain angle, which is bent at a certain angle. It is like seesaw, right? So that it is mounted on the hinge at B. So it is mounted on the hinge at B in such a way. Suppose using force P, this part is pushed down. So this A will go up. Hope you understand. Now, in the given mechanism, hinge reactions are not required. So we should rotate the beam about hinge only. Since we do not want hinge reaction, you should rotate the beam about B. Okay. So in that case, only force P will do work and 1 kilonewton will do work. So what we decide? We decide that lever mechanism is rotated by small angle theta about B. Then we'll see that which forces will do work. Of course, HBVB reaction at hinge will not do work. So here this diagram has been drawn. This is mechanism diagram. FBD or lever mechanism. This is AB. This is BC. All right. This slight misprinting has happened. Do something. This is continuous line. All right. It is rotated by small angle theta. Okay. Now we find AA1. A1. This is length. Is given to us 15 centimeter in this right angle triangle. All right, this is given 50 centimeter, A1B. So length AB is first to be found. So AB length is going to be 15 square using Pythagoras theorem. This is 50, this is 15 from the diagram. So 15 square plus 50 square, square root of that, that is 52.2 centimeter. Then you come to this side. On this side, BB1 is given to you as 40 centimeter. And B1C is given to us 40 centimeter. So BC length will be 40 square plus 40 square square. Okay. Now this angle alpha can be found. Tan alpha is equal to 15 upon 50. So that gets you at alpha. Now we resolve this 1 kilonewton. This link, this AB is making alpha with horizontal. So normal will make alpha with vertical. So this is normal. It make alpha with vertical. So we can resolve 1 kilonewton, 1 cos alpha, and 1 sin alpha. You have rotated this by a small angle theta. Mind it, theta is very small. So this part will also rotate by small angle theta. Now, here P force is applied. Here force P is applied. Now, as you are rotating in clockwise direction by angle theta, P will do positive work. Work done by P is going to be what? P into CC dash. Work done by 1 cos alpha will be 1 cos alpha into AA dash. But work done by 1 cos alpha will be negative. 1 sin alpha will not do any work. So we have written that principal of virtual P into CC dash minus 1 cos alpha into AA dash. What is going to be CC dash? BC into theta. 1 cos alpha. Alpha value has been substituted. A dash is what? AB into theta. We know the length BC, 56.57. All right. Theta gets cancelled. And minus 1 cos alpha into AB length is 52.2 equals 0. You get the value of P as 0.884 kilometer. This. All right. Slight misprinting has happened. I hope you can understand. This dotted line is continued. Here continuous line is continued. Here there is a force P applied. In this mechanism, HBVB will not do any work since the lever mechanism has been rotated by small angle theta in clockwise direction about B. So there is no displacement in the direction of HB and B. All right. Now, next we take a beam reaction problem where you have the beam, continuous beam with the internal hinge. You have the So you are given with the beam like this. You see that? You are given with the beam which is hinged, roller supported at A, hinged at B, roller supported at C, and in between at point D, it is connected by internal hinge. Right? Internal hinge reactions come into consideration when the parts are separated. Internal hinge reactions are come into consideration when the parts are supported. So first we draw free body diagram of the Here, students, you can draw the free body diagram. You can consider the mechanism for the entire beam, or you can consider it for the part beam after splitting at internal hinge. Like first, we have drawn the given beam as it is. This is roller support, so reaction BA. Roller support at C, BC. Hinge at B, HB and BB. This is external movement, anti-clockwise 20 kN. This external load 8 kN. This UDL has been replaced by point load 4 into 2, 8 kN. All right, this by mistake it is printed as 9, it is actually 8. All right, now the first mechanism what I have considered is for part DC. That means when I'm showing this mechanism, it means that I have splitted the beam at D and I'm considering the mechanism for only right hand side part. When I have splitted the beam at D, HDVD will come into consideration. But I have rotated the beam DC about D in such a way that HDVD will not do work by small angle theta. So that virtual displacement at this along the line of action of 8 kilonewton will be 1 theta at 1 meter. This is a 2 meter. This is 2 theta. So mechanism 1, to find VC, rotate part DC about D, so that HDVD will not do work. Only VC and 8 kilonewton will do that. So work done by VC is positive, VC upward, 2 theta is also upward, VC into 2 theta. 8 kilonewton is downward into 1 theta is negative, equals 0, you get VC. All right. Then we are considering the entire beam together as one unit, but I am lifting the internal hinge by delta. But mind it, here still you are not changed the geometrical condition. See, beam AD and CD were straight. So still we have kept them straight. This is AD is still straight. This is CD still straight. So you have just lifted it by small amount, right? So that this rotates by theta. So of course this will rotate by theta 1. I'm considering the virtual displacement, vertical virtual displacement at the internal hinges delta. So now you can relate theta and theta 1. How you will relate it theta? See, delta from left hand side is what? Delta, this point AD length is 5 meters. So this is 5 theta 1. All right. This is 2 theta. 2 theta is equal to 5 theta 1. Theta 1 is 0.4 theta. So in the mechanism 1, HDVD will not do work. In the mechanism 1, mechanism 2, the second mechanism which we are talking about, HDVD will not do work. Why HDVD will not do work? Because beam has not been splitted. Beam has not been separated. Right? Here it is rotated about C, VC will not do work. It is rotated about A, VA will not do work. So here which force will only do work? VB. Even HB will not do work because there is no horizontal displacement. So this virtual displacement will be 2 theta 1. This is at 4 meter from A, 4 theta 1. This is at 1 meter from C, 1 theta. Right? And this is delta, which you can call it as 2 theta or 5 theta. Now mechanism 1 to find VB. VB will be obtained from this mechanism. Work done. Let's start from the left hand side. Minus 8 into 2 theta 1, negative. Right? This is movement is acting anti-clockwise. You have rotated this part anti-clockwise, so work done will be positive. Plus 20 into theta 1. Then work done by VB. VB is upward here and displacement is up. VB into 4 theta 1. Minus 8 into 1 theta. You substitute. Substitute the value of theta 1 as 0.4 theta, which we understood here, relation between theta and theta. And theta gets cancelled from all terms. You get VB as 4. Right. Now, after this, you want to find VA. To find VA, you should consider free body diagram of part AD and rotate the beam about D, so that HDVD will not do work. HDVD, because you have splitted the beam and you are rotating the beam about D, so that HDVD will not do work. But yes, VB will do work. VA will also do work. All right. So mechanism 3, this is for VA. Algebraic sum of the work done. VA into 5 theta, because it is at 5 meter. Minus 8 into 3 theta. Work done by VB is upward into 1 theta, positive. See, work done by VA is positive. Work done by 8 kilonewton is negative, minus 8 into 3 theta. Work done by VB is positive, plus VB into 1 theta. Then work done by movement. 20 is anti-clockwise, rotation is clockwise. So work done by movement is negative. Minus 20. Right? Theta gets cancelled from all the terms. You get VB, value of VB also to be substituted 4 kilonewton. You get VA as 8 kilonewton. Right? From mechanism 1, you got VC. Mechanism 2, you got VB. And mechanism 3, you got VA. What is still left out? HB. For HB is the horizontal reaction. So you should give the virtual displacement to the entire beam by delta towards right, so that all points will have the virtual displacement of delta towards right. Let's apply principle of virtual work on mechanism 4. Only horizontal forces are to be considered. There is only one horizontal force on the FBD, that is HB. So HB into delta equals 0. So of course HB will be 0. Of course HB will be 0. So here we can consider free body diagram of entire beam, or you can consider FBD of the part of the beam after splitting at internal. But after splitting at internal hinge, like in mechanism 1 or in mechanism 3, you should make sure that HDVD will not do work, because you should rotate it about internal hinge only if you have split it at internal hinge. This is what is the precaution required. Now we'll take one problem, students, which is with two internal hinges. We'll take one problem with two internal hinges. This precaution has to be taken care of even in this problem also. As and when you are splitting the beam at internal hinges or at a, you should make sure that you should rotate about internal hinge, and also make sure that AH1, H1, H2 and H2C are the three different parts which are straight should remain straight, whatever way you give the virtual displacement. So for this beam, A's fixed support will have three reactions on the FBD. This is B's roller support will have one reaction vertically upward. C will have vertical reaction. Right. This 10 kilonewton is at 60, so you can resolve it 10 cos 60 and 10 sin 60. 10 cos 60 is 5 and 10 sin 60 is 8.66. Rest all loads have been shown. One has been 1 kilonewton per meter UDL has been replaced by equivalent point load 1 into 4, 4. Right. Then first mechanism we have considered to find VC. We have considered FBD of part H2C and we have rotated the beam about H2 so that internal hinge reaction at H2 will not be found. This is we have rotated by small angle theta, right? So this will be 2 theta, this will be 4 theta. Algebraic sum of the work done will be VC into 4 theta minus 10 into 2 theta equals 0. VC is 5. Then in the next mechanism 2, we have splitted the beam at H1. So left hand side AH1 has not been considered. So you are just pulling the internal hinge H2 by amount a small virtual displacement y, so that right hand side part H2C is rotated about C by small angle theta 1 and H2C is H1 H2 are rotated by small angle theta. Y is equal to, from the left hand side is equal to 8 theta, from the right side it is equal to 4 theta 1, so that theta 1 is equal to 2 theta. Now here this point is at 2 meter, so 2 theta. This is a 4 meter, 4 theta. This is at 6 meter, r theta. You consider it r theta because we are considering theta is very small. So this ordinate will be r theta. 4 meter is r 4. This is 6 meters radius here, 6 theta. This is 8 theta. And so this is from the right hand side, this is 2 theta 1. And theta 1 is 2 theta, so it becomes 4 theta. So let's apply for this principle of virtual work on the second part, which will get me the value of D. Right? Now let's start mechanism to find it. Algebraic sum of the work done. So here vertical force will do negative work, minus 8.6 is into 2 theta. VB is upward, displacement upward will do positive work, VB into 4 theta. This 4 kilonewton will do negative work, minus 4 into 6 theta. Since force is downward, displacement is upward. Here there is no force because you have not splitted the beam at internal hinge, so internal hinge reactions will not come into consideration. Minus 10 into 4 theta, negative work done. That's it, equals 0. You get VB as 20 pounds. In the next mechanism, you want to find MA. You want to find MA, right? So we have considered FBD of beam after splitting at H2. We have taken left hand side part AH, right? So in such a way that there is no H2 reactions will not do work. We have just lifted it by Y, so that left hand side part is rotated in anti-clockwise direction by small angle theta 1. Right hand side part is rotated in clockwise direction by angle theta. This point has been lifted by small displacement y. So y from the left hand side will be 2 theta 1. From the right hand side, it is at what distance? 8 meters, so 8 theta. Y is equal to 2 theta 1 is 8 theta. So theta 1 comes out to be 4 theta. What is theta 1 is equal to 4 theta. Theta 1 aa gaya idhar by mistake. Theta 1 is what? Equal to 4 theta. All right. Now start right. Here HAVA will not do work. Work done by MA. MA is anti-clockwise. Rotation is anti-clockwise. Work done MA into theta 1 minus. Sorry, in mechanism 3, MA is anti-clockwise, rotation is anti-clockwise, so work done is positive, MA into theta 1. Theta 1 is 4 theta, directly substitute. Minus 10 into 1 theta 1, so this is also equal to 4 theta. Then 8.6s will do negative work, minus 8.6s into 6 theta. VB into 4 theta will positive work, minus 4 into 2 theta. And that's it. Here VB values to be substitute 20.33. MA is obtained as 4.66 kilonewton. Now to find VA, we are considering FBD of part AH1. After splitting at H1, only left hand side part, and I'm rotating the beam by small angle theta about H1, so that internal hinge reactions will not do work, and only VA, MA, and 10 kilonewton will do work. So this is at 1 meter, it is 1 theta, at 2 meter, it is 2 theta. But algebraic sum of the work done. VA into 2 theta will do positive work. MA is anti-clockwise, rotation is MA is anti-clockwise, and rotation is clockwise. So work done by MA will be negative, minus MA into theta. Work done by 10 is also negative, minus 10 into 1 theta. Right? Theta theta gets cancelled. Substitute the value of MA 4.66 kilonewton meter. You get the value of VA at 7.33. All right. Now you have to find horizontal reaction. To find the horizontal reaction, you have displaced the beam by small linear displacement, virtual displacement delta towards right, so that all points on the beam will have the virtual displacement delta towards right. Let's start. HA is towards right will do positive work, HA into delta. 5 kilonewton is acting towards left will do negative work, minus 5 into delta equals 0. Delta delta gets cancelled, you get H. So this way you got all the reactions by virtual work method. We could have solved this problem by equilibrium conditions also. In the examination, if they do not mention the method, you can solve the problem by virtual work method or by equilibrium conditions method. But still, I suggest you to solve the problem by equilibrium conditions only, right? You should solve the problem by virtual work method only when they ask you to solve the problem by virtual work, because virtual work solution is little lengthier. Virtual work solution is little lengthier. It is clear? Now we come to next problem. That is problem number 6. Let's read it. Two masses M1 and M2 are resting in equilibrium on two smooth inclined planes. Two masses M1 and M2 are resting in equilibrium on two smooth inclined planes AB and AC as shown in the figure. Planes AB and AC make angle θ1, θ2 with horizontal respectively. Using concept of virtual work, show that ratio of masses M1 and M2 is given by M1 upon M2 is equal to sine θ2 upon sine θ1. Well, students, he's simply asking you certain relationship. He's not asking any tension, so string should not be cut. We take FBD of the entire system as 1 unit. I took the FBD of the system as entire 1 unit. What forces will act over here? Weight will act vertically down, M2G. Here weight will act vertically down, M1G. Normal reactions here, say N1, here is N2. Here this plane is making angle θ2 with horizontal, normal will make angle θ2 with vertical. So this is M2G cos θ2, M2G sin θ2. Here this plane is making θ1 with horizontal, normal will make θ1 with vertical. So this component M1G cos θ1, M1G sin θ2. Now the entire system is given virtual displacement. We give virtual displacement to block 1 by linear displacement. We pull it down by delta. Let us give virtual displacement to block 1 delta as shown. That means block 1 is pulled down by small amount delta as marked. So which forces will do work whenever we apply principle of virtual work? Tension, the string will not do work. Normal forces N1, M1G cos θ1, N2, M2G cos θ2 will not do work. Only here M1G sin θ1 will do work. So this is acting downward, down the plane, displacement downward, this will do positive work. M1G sin θ1 into delta. All right. Here M2G sin θ2 is down the plane, displacement upward will do negative work. Minus M2G sin θ2 into delta is 0. Delta delta gets cancelled, G gets cancelled, so you get M1 sin θ1 minus M2 sin θ2 equals 0, or M1 upon M2 is equal to sin θ2. This way, what he wanted to prove we have. So students, this is my first lecture on virtual work. This is first part of the lecture. There will be one more lecture of this, which will be based on other sign convention, that is coordinate axis sign convention. This problem, 6 problems I have discussed, covering beam reactions or beams with internal hinges, or one or two problems based on general concepts of equilibrium. All right. In the second part of my lecture, you will have 8-9 problems on coordinate axis sign convention. All right. And make sure that you are sharing the QR code of my YouTube channel with your friends so that they are benefited. There is no cost for that. It is totally free. Please share with your friends. Right, for more solved problems, more theory, MCQs and all, you can refer to my book on engineering mechanics, for which is available on Amazon. Link to buy on Amazon is given in the video description of every lecture. All right, book is available on the local bookstores also. Right. Please keep on subscribing my YouTube channel so that you'll get the notification as and when the new videos are. Okay, students. Thank you very much.